I've recently enrolled in a study to integrate a modified version of Infineon's tri-core processor into my brain. Hopefully, I'll be able to simultaneously handle different instruction sets like boss++, wife sharp, and kids.chaos. While the study is fake, the tri-core architecture is real, and it makes life easier for safety applications. Marcelo Williams is here to tell us more about it and how Infineon is making it easier than ever to integrate safety into your next design. Welcome to Tech Chats, Marcelo.
Thank you. It's always a pleasure.
Let's just start with how and why Infineon came up with AURIX MCUs.
It's a very interesting history with AURIX. AURIX was born for more transportation usage, but during the evolution of many different applications that require safety, security, fast processing, AURIX is gaining even more traction on applications that are not just automotive or transportation related. So we have power tools, we have elevators, we have multiple applications that now requires all the features that AURIX are capable to offer with. So that's why AURIX is now on the mainstream.
So what does the AURIX portfolio look like?
So the AURIX portfolio, we have multiple devices that we call it AURIX first generation, second generation, and third generation. The generation, it's the part number -1. Why? Because we had a first device called Aldo that was TC1. So then you always mention AURIX TC2 for AURIX first generation, AURIX TC3 for the second generation, and now the new one's TC4 for the third generation. What is interesting is Infineon would not putting end of life the old generations. The new generations are just adding more features and more capabilities. We still have the Aldo on production nowadays because Infineon guaranteed this production for at least 15 to 20 years. So it depends on what the customer needs, how many multi-cores they need, or how many power processing, flash size, or pin packages. They can choose which AURIX fits better their application. So AURIX can offer you the higher performance in our portfolio with many peripherals that is a heritage inside microcontrollers from Infineon. So what we have inside AURIX, we have the scalable family concept. So you have a multiple pin packages inside different families. Plus, you have a very nice ecosystem that combines with this premium service. As well, you have the automotive security and functional safety as well. It was born for automotive, but now you can use in different applications, including consumer and industrial, that requires these peripherals. And on top of that, you have the quality and the business continuity that was born for automotive and now is expanding more for industrial and consumer applications as well. And now with the expansion of safety capabilities, peripheral capabilities, processing capabilities, AURIX is covering many other applications inside automotive parts. So not just the ECU, but gateways, comfort models, clusters, the telematics applications as well. And now we are using this for industrial applications for multiple controllers, inverters, battery chargers, and multiple different applications.
Now, you have multi-core, tri-core devices. Can you explain that and what tri-core is?
Why the tri-core is called tri-core, okay? Tri-core, they accept 3 different sets of instruction. They had a microcontroller set of instruction, a RISC processor, and a DSP. What it was this important. It was the first time in history that one microcontroller can make a full ECU feature set for a combustion engine. It was a milestone for the automotive industry, and today we have more than 500 million devices shipped in multiple car platforms, consumer application, and industrial motor control as well. Here we go up more deep, but it's very interesting that you can see on the squares that you take the most important or the most used set of instructions of each one of the cores, and you are capable to combine them, and then you are capable to do everything in one single microcontroller using 3 different sets of instructions with multiple CPUs. But what I want to make it clear, it's the tri-core is one CPU, but they can have nowadays up to 6 CPUs running in parallel in the same device.
What are you doing differently in each generation?
It's the capability of a flash per device. So today we are capable to offer up to 32 megabytes of flash in the RX new generation. And we have 6 multi-core running in parallel. With these cores running in parallel, we are capable to implement functions that in the past you need at least 2 microcontrollers to deal with. For example, safety. With multiple cores running in parallel and many other peripherals on AURIX, you're capable to use one microcontroller and take these CPUs to take care of each other. So then you can have one microcontroller doing a high level safety, even ASIL-D classification in one silicon, which is very interesting because then you can reduce cost, you can enhance processing capacity, and you can reduce BOM and space on your PCB. And as you can see, you can cover multiple applications that goes from the basic and engine management now to the BMS or to the inverter as well to control multiple motor controls and torque and electronic power steering wheel, just to show that's what AURIX is capable for. And then AURIX can fit well for these applications.
What about compatibility and reusability between generations?
Yeah, this is a key point. So one thing that AURIX did is try to do as much as you can software and hardware reuse. Even if you move from 3 to 6 cores, you can reuse your software. You just develop the new software for the new 3 cores. You can use the same functional safety compliant from the previous to the new one. We upgraded the full Evita support. This is the security part. They have the peripheral set. One thing that we did is, even though the peripheral it's improving, they still have software compatibility with the previous versions. So if you have a peripheral that is already validated and you don't want to touch it, you can keep using your code on these devices as well, the new generations. And one thing that is a big step, especially on the new AURIX TC3X, is the full support of software over the air, or SOTA. In the past, you have to do all the control by the software part, which is very complicated. And by now, you have the help of the new hardware done it for you.
What about scalability?
Yeah, the scalability was something that when we start developing this new TC3X family, we make sure that we have some compatibility on performance and package. So as you can see, if you go to a package that is very common in the industry, the LFBGA292, you have all families from 1 megabyte, 300 megahertz, to up to 16 megabytes, 6 core at 300 megahertz. And you see the applications on the right side. You can go even to the domain control, gateway, cameras, everything that needs high power processing. But at the same time, we want to make things simple to the applications that used to be very simple, and now they are becoming more complex, like body applications, okay? So for that, they need a more powerful microcontroller. That's why you have these smaller form factors, let's call it like this, for AURIX, to address these applications that are evolving from former 8-16-bit devices to a 32-bit devices with more capability like AURIX.
And what about the partnerships you have with some of the CPU and GPU-based autonomous driving platforms?
So these very powerful processors, they are very good to learn and sense the outside world, okay? But someone has to take the decision. Someone has to actuate, someone has to turn on and off, someone has to take the car control in case if needed, someone has to shut down a machinery, so someone has to do the dirt job. So that's how AURIX is playing here. We are not competing with these guys, we are creating a synergy, and that's why AURIX is being so successful in these markets.
So what kind of applications does AURIX fit into?
So talking about the applications for AURIX TC2 and 3C3, you see the applications like powertrain, chassis and safety, and body advanced connectivity. Even those markets are changing and now are mixing applications, but AURIX is a good fit for each one of those. And we offer the AutoSAR, that is the real-time operational system for automotive applications. We offer the functional safety and the cybersecurity in all AURIX family. Same for the industry. You have multiple applications, power and energy, smart vehicles off a highway, that are drones, that are CAVs, that are forklifts. You have the factory automation, and you have the radar applications like medical. In this case, you have the safe RTOS. And we're still offering the functional safety and the same cybersecurity that were required for automotive in this consumer and industrial markets as well.
Obviously, these applications have stringent quality requirements, and you have this zero defect program to go with AURIX. Tell me about that.
Yeah. Since AURIX was born for automotive quality, it was mandatory since the inception. And to make it happen is not just a development process flow that we have to follow. You have to be sure that you achieve the automotive qualification. So we make sure that every single AURIX that move out of the production pass by all these 4 steps and achieve less than 1 product per million. Okay, and even 1 product per million today in automotive standards, it's considered high. So they are now targeting 0.1 part per million, and they are targeting to be achieved by 2025.
We talked about more than just automotive. How are you addressing the certification requirements for all of these different industries?
There are different safety standards for each one of the markets. But one thing that is very interesting, it's we took one safety standard, that is the IEC 61508, that cover most of these standards already. So what we did, we classify AURIX inside these standards, okay? And then it means that cover most of the safety function standards required by the industry. So no, not just automotive, but railway, aviation, and we have other applications like a process industry and nuclear power as well. So this does not mean that we don't have the ISO 26262 standard certification as well. It means that we did the master one, that is the IEC, and then for each one of the markets, we can offer a different certification. But usually the customers has to do these certifications as well by product. So we provide all the documentation and they can move from there onwards. One thing that I want to mention about the robust part of the AURIX related to the safety application is the AURIX observation points with the competitors' observation points, okay? It's every single yellow point here in the figure on the left side is observation point. What is the observation point? It's not just for the debugging system. It's something that's on fly. The microcontroller is checking these observation points, and if it's something failure, they can take a decision. The AURIX devices can take a decision what they will do. If they keep working, if they go to a safety vector part, if they move the content from here to there, if they use a different route for that. And if you compare this to the competition, usually they use a crossbar that is a singular crossbar, controlling all the peripherals. So if you have an issue on this crossbar, it becomes a bottleneck for your application. And you cannot rely safety applications when you have one crossbar only. You should have multiple crossbar, otherwise you don't have redundancy. So this is a very good point for AURIX, positive point for AURIX, that we have many observation points running in parallel in multiple crossbars. So this is clear on this slide that you can see the multiple observation points on AURIX TC2 and the AURIX TC3. And then you can see the evolution why we're talking about AURIX second generation, third generation, and fourth generation, because we are including more observation points on the right side. So then it becomes even more safer. Oh, Marcelo, why is that needed? When you are moving your ASIL certification, A, B, C, or D, as many points, observation points you have, it's best, because then you can make sure that your device is even more safer. And one thing that is very interesting to mention as well is, as you can see on this slide, on the left side you have the AURIX TC2X, with the safety lib. The safety lib is the software part that implements all the safety requirements to make this device a ASIL qualified device. What we did on the AURIX TC3, we implemented most of the safety lib on the hardware. This evolution is always ongoing, but this does not mean, as I mentioned before, that we are putting end of life previous generations. It's just to make your application less complex.
There are some real concerns with what a hacker could do if they got into a vehicle system. So let's talk about how AURIX keeps things secure.
Yeah, this is an important point that nobody used to address it before. We have many histories in the internet that you can figure out that people are hacking cars, or they are able to break the codes or copy parts as well. And this is one thing that we enhance on AURIX. We already have this available on the TC2 family, and we enhance in TC3 and TC4 families now. That is our security part, okay? And for that, the figure that you are seeing here in the slide, it's a model that is inside any AURIX. And as you see in the description, they have their own ARM 32-bit microcontroller separate by a firewall. What it means, this is another microcontroller inside a microcontroller. And how it works, this microcontroller, they have a software that runs inside them. You can program by yourself, or you can license this software from multiple providers that they can offer you different levels of security or different features, okay? And this microcontroller, they have the function to isolate the multiple peripherals of the microcontroller. So in case you have a hacker trying to get inside an AURIX and they realize that they are attacking one specific peripheral, this microcontroller can isolate this peripheral like a cell, and then can keep the other part of the microcontroller protected. So which means that even though someone tried to hack a flash or one CPU or one peripheral, this microcontroller create a firewall to the other parts of the micro, avoiding them to get inside the full microcontroller control. And how we implement this? We have a software portfolio, the AUTOSAR basic package, and we have other libraries that runs inside this part. And it depends on what you really need, okay? You can run this software package for the AURIX completely. You can run for each one of different peripherals. But one software package that is very common, and we'll mention later onwards, is the ILLD, is the Infineon low-level drivers. The ILD is the abstract the layer of the hardware between your main software operational system or your application to the AURIX drivers. Since they abstract the low-level drivers, you can have an easier portability from one AURIX to the other one.
At the beginning, we mentioned making this easier for designers and developers. So let's talk about your tools ecosystem and how someone can get started with AURIX.
We have, as I mentioned before, a very complete software ecosystem and tools. One thing that we created is we call it AURIX Ease of Use. And this kit, you have multiple connectivities. We offer with this kit as well example codes. We offer the ILD, and we have also the user guides to get started with the AURIX. What is the key for the ease of use? We created something that we released last year. It's called AURIX Development Studio, okay? It's a free compiler and debugger. And on top of that, we have all the quick training videos, we have expert trainings, and we have the GitHub with more codes examples that you can use on your development. On top of that, you have other kits, and then you can get into more complex applications with AURIX. But coming back to the simple kit, you have an Arduino interface. So if you have any sensor, any other connectivity board that you want to put on top of that, plug and play. You have the Shields to Go platform. The Shields to Go are sensors from Infineon, are boards from Infineon that you can put on top of that. So if you want to test pressure sensor, if you want to test a 3D sensor or any other sensors from Infineon, you just take your Shields to Go board, put on top of that, and it works. And one thing that we did on all XMC devices, and now we bring to AURIX as well, is the micro bus connector. So if you want to test something, if you want to plug and play from a single relay to a GPS system, you can use their connectivity. Oh, Marcelo, can I get more information about which kits are more complex for AURIX? Yes, you have the application enablement kits. These kits are much more complex kits, but they are ready to go platforms.
Now, this is getting more into the business side of things, but explain what Infineon is doing to prevent supply disruptions and ensure customers can get product when and where they need it.
To avoid what's happened in the history of automotive industry, where we had the issues with tsunami, all climate things, and now with the virus, we create some mechanisms to avoid disruption in our production chain. Okay, so what we did, we have a dual fab concept. So we have a fab in Germany, in Dresden, and we have a fab in Singapore, and now we are extending this to Philippines as well. So if you have any issue with one of those factories, the other factory can take over and maintain the production so you don't have disruption. This helped us a lot during these COVID times, because then we can have multiple locations providing devices for the local markets, which avoid many of the disruption that can happen on the logistics side. Okay, we have supply chain buffers, so we have what we call it distribution centers, our DCEs, in other locations. So we have in Malaysia, we have in US, we have in Europe another one. So what we did, we have buffers on these DCEs, where if something happens with the factory, we still have the distribution centers capable to deliver these parts until we get anything that happens with the factories fixed. Okay, and we have a mechanism called EDI, that is a early detection system of natural hazards in critical incidents. They did a very good preparation for the COVID. That's why now we are back after all the situations, and we don't have any issues or any shortage with our automotive products, including AURIX. So they did a very good job on that. And business continuity plan. So you can have all the threads that you will not avoid on the left side, but AURIX delivers. If you want to learn more, you can go to infineon.com/AURIX. You can go to the infineon.com/makers. You have all the hardwares and softwares and the latest news that we have. Or you can go to Infineon.com. We have our e-learning platform as well, where you have hours and hours of material available for not just the microcontrollers from Infineon, but for our entire portfolio.
Thank you, Marcelo. Once again, that's Marcelo Williams from Infineon Technologies. If you'd like to learn more about Infineon's AURIX Microcontrollers, click the links in the description or visit Mouser.com. And be sure to check back soon for the next episode of Tech Chats.